This chapter is about something called hypothesis testing. Every research study that's conducted, at least most quantitative research studies, involve testing some sort of hypothesis. And this is based in something actually called the null hypothesis, which in essence means there is no difference between two things, or sometimes three things or more. Sometimes it's done verbally, sometimes it's done numerically. So, for example, I could say that there is no difference in the GRE scores of men and women. That's verbally what that would look like. Numerically, that would look like this. This is called mu, because this is the population of men, the population of women. I'm saying there is no difference between those scores for those two groups of people for their GRE scores. They don't have to be scores. They can be correlations, they could be standard deviations, or anything else. And we're going to skip this part where we talk about creating your own. But basically, some of the things that come up are you could say that there's no difference between the average scores of ninth graders and the average score of 12th graders on some memory test. You could say there is no difference between the effectiveness of community-based long-term health care for older adults and the effectiveness of in-home long-term health care for older adults. You could say there's no relationship between reaction time and problem solving. So that's an example of a correlation. You could say there's no difference between white and African American families and the amount of assistance offered to their children in school-related activities. And what you're trying to do is determine whether or not you can reject that hypothesis. And these aren't really made up. Those are some examples that I have out of a book. We don't make them up, just like you're not making up your research. You're conducting a literature review to determine what we already know about it, and then you're going to make a hypothesis that is going to be tested. We're not out to prove. We're only seeking to reject or fail to reject the hypothesis, and this is where this can get confusing. If we reject the hypothesis, then we're suggesting that statement where these two things are equal is not true. So, for example, if I reject this statement that the GRE scores of men is not equal to the GRE scores of women, if I reject that, then basically we're putting a hash mark through that equal sign and we're saying that they are not equal. That's all that we can say. Now, in this case, if we reject that, we're going to know which scores are higher than the other. But very often, if we have 3 or 4 groups that we're looking at and all we did is reject part of it, then we still don't, there's a lot that we don't know. This other part about taking a hypothesis, we'll put that into a discussion thread. So that's a null hypothesis. An alternative hypothesis means that we're going on a limb and we're saying something's greater than something else. Non-direction means that we don't know what to expect, but we just think there is a difference. So we could say that there is a difference between the GRE scores of males and females. There is a difference in the 9th graders and 12th graders, but we don't know where it is. That's a non-directional. Directional means we're taking a stronger chance. Not only are we saying that there's a difference, we're saying where the difference is. So we're saying that the GRE scores of women are greater than the GRE scores of men. That is a directional hypothesis. It's going further than saying there is a difference. We're saying where the difference is. You will also come across something called tails, a one-tailed test or a two-tailed test. And what they're talking about is if you go back to the paper with the one that looks like this, if we say it is a one-tailed test, this is the tails that they're talking about. For example, if I say that GRE scores of men are higher than the GRE scores of women, well, now I'm only dealing with one half of this. Remember, the scores can be normally distributed. So the GRE scores of men, I'm saying, are higher than the GRE scores of women. I'm going to test that hypothesis. If I'm saying there is a difference, remember, that's non-directional, but I don't know which way it is. That's also called a two-tailed test because there's a tail here And there's a tail here. So it may be that the men are here and the women are here, or it may be that the men are here and the women are here. I'm leaving open the two possibilities. So what happens next? Well, we go out and we collect data. We want valid data. We want reliable data. We need an excellent sample. We've gone through the sampling chapter. We want a sample that looks like our population. We want to make sure that the instrument that we're using is accurate. We need statistical data to make sure that if there's a difference that we can identify where the difference is. We want a level of significance that is acceptable. And if you remember back a couple of chapters ago, we talked about having a p-value that is less than 0.05. And that means we're saying that 5 times out of 100 we're willing to say that something's true that's not. And we can't accept that, but that is the minimum that we can accept. The critical value is calculated by a computer. So you're going to come across a t-score for t-test, an f-score for something called ANOVA, and we'll get to these later. The level of significance, this p-value, can be adjusted higher if they need it to. And when we say higher, what we mean is tighter. So instead of it being 0.05, it could be 0.01 or 0.001. But if they're going to adjust it, they need to tell you that up front, and they'll tell you what level of significance they're willing to accept, and that's something that will come up in the lit review. One of the things that's challenging to process with this is we're talking about making a guess about a population. So for example, if we're talking about 9th and 12th graders, we can't really sample all, we can't get the data on all the 9th and 12th graders. We're using a very, very good sample to make an estimate about the population. There's a chance that we can be wrong and that we can make a mistake, that we say something that's true that's not. And one of the things people ask was, well, how do you know? Well, we don't really know for sure. If we really knew for sure, if we really knew every single score on the 9th graders and every single score on the 12th graders on something, there wouldn't be a point in doing all this, but that's impossible to do. So we have to use statistics to be able to make an estimate of what's happening. When you look at what can happen, there's 4 things that can happen. And for this example, we're going to need something called the null hypothesis table. So we want to look at this table, and there's 2 things that are happening when we're making an estimate about all this. We have what is true of our sample and what is true of the population. And remember, all we really know is what is happening here. We're making a guess about this using this. So for example, if your sample says that there is a difference here, and in fact your population has a difference, if you could really go into the population and get everybody, then you've said something about the population that is true, and that's fine. If you say there is no difference in the 9th grade scores and the 12th grade scores, and in fact there really isn't, if you can actually get in and see everybody's scores, you'd say there is no difference. That's fine. We can live with these 2 things. If you say with your research that the sample says there is a difference, but in fact the population has no difference, you say there's a difference in 9th and 12th graders, but actually there's not. Now you've said something that's true, which isn't. And that's called a false positive error. It's also known as a type 1 error. That's bad. If for some reason you conduct your research and you say there's no difference between 2 groups, and in fact there really is, that's called a false negative. You failed to say what is true. The problem with this is like having a jury trial. In a jury trial, the jury doesn't really know for sure who committed a crime. It's only the person who committed the crime, and if the victim is there, the victim. If the jury says somebody is guilty who is not, then they have convicted an innocent person, and the guilty person got away with it. So two bad things happen. If down here they fail to convict the guilty person, well, that's bad too. We don't like that either. But at least they've not convicted the wrong person. So here, one bad thing happens. Here, two bad things happen. So let's go over this again. This is called a false positive. When you say something is true that's not, that's a false positive error, a type 1 error. When you fail to say what is true, it's called a false negative. And that's down here. It's called a type 2 error. They're both bad. This one's worse. We either reject the null hypothesis or fail to reject the null hypothesis. We don't say that it's true because we can't ever really know for sure. We'll never know for sure about any of this. We're just making a highly educated guess about that. And we don't know for sure what the population parameter is. We are making our best estimate of what we think is happening. So when people say, well, how do you really know what it is? We don't. It's just a guess. And that's why we've got to be sure about having good samples, good data, statistical analysis, good instruments to make sure that if we are saying a program works in education, that we can really be confident that the thing that we've put forth is the thing that's making the difference. And we're willing, as we said, we're willing to make a mistake. We're willing to make a mistake 5 times out of 100 or less, and we can live with that. That means 95 times out of 100, what we are seeing is really what is happening. So this p-value is our magical value. People say, well, what if I'm close? What is 0.051? Well, being significant is like being pregnant. You can't be almost pregnant. Either you are or you aren't. This is either statistically significant or it's not.